Hey everyone, this is Daniel for Rock the JVM. Thank you so much for coming to my talk on full stack Scala 3 development with the Typelevel stack. I'm super excited to be at this conference for you and talk about some architectural decisions and some good practices for building Scala 3 applications in a full stack way with the Typelevel stack. My name is Daniel, and I founded a little website called Rock the JVM, which is a learning platform for pretty much everything in the Scala ecosystem. I've been a Scala developer and teacher for more than 8 years now, and I've had the privilege of teaching more than 80,000 people all over the world, and also training high-performance teams and some of the high-profile companies around the world like Apple and Adobe and so on and so forth. My specialties include everything in the Scala ecosystem, including functional effect systems, Akka, Apache Spark, and many other tools. My website is rockthejvm.com if you want to check out my work, or you can reach out to me at daniel@rockthejvm.com for any questions or any comments about this presentation or pretty much everything related to Scala. And I'm also active on all socials, LinkedIn and Twitter and YouTube and so on and so forth at rockthejvm if you want to check out my updates as well. Okay, so I made an app. It's a jobs platform that I personally made for my own students at Rock the JVM. We have a private community there of more than 2,000 people, and many people are asking in that private community where they can find job offers, if we can help each other with resume preparation, reviews about companies, and so on and so forth. So instead of just chatting there, I just created this application for them so that anyone can post their job offers, so companies can post jobs there, and my students at Rock the JVM can apply. And I've made this application public at jobs.rockthejvm.com, and you can actually try it right now. So if you're a company here that has come to the conference looking for Scala developers, you can actually post a job right there. The application is at the moment completely free, and I'm personally going to promote your job offers to my own student base here at Rock the JVM of more than 2,000 people. Now, from the technical point of view, this application is a full-blown product with all the regular features that you would expect from a web application. So it's a CRUD application. This is absolutely standard, but beyond that, we have full user management with role-based access control. So you have admin roles, we have recruiter roles, we have standard roles, each with their own permissions. So we have permission control. We have email-based password recovery with recovery tokens with expiration date. We have real credit card checkout. We have incremental loading and pagination on the backend and on the front end. We have markdown rendering if you want to post a job offer with some complex descriptions there. We have image compression both on the front end and on the back end. We have user input validation on the front end and on the back end validated with the CATS functional programming library. We have user session management and all sorts of features that make this a full-blown product with a real development experience. So I'm going to talk to you about some architectural decisions and about some good practices that you can also take away for your own products if you're interested. So, the application is built with the Typelevel stack in the sense that we have the CATS functional programming library for functional programming principles and also data validation. We have CATS effect for pretty much every action that we perform on the back end of the application and also on the front end. We have Doobie for database management. We have HTTP4S for the REST API plus the authentication and authorization services. We have authorization with JWT, so JSON Web Tokens, with role-based access control. And we have a nice functional programming library called Tyrian, which holds the entire front end. Tyrian is also based on the Typelevel stack. It's based on CATS effect and FS2. Now, besides these, I also use a bunch of other libraries in the Typelevel ecosystem for all sorts of other functionalities of this application. For example, I use pureconfig for configuration and automatic type class derivation, which is absolutely phenomenal in Scala 3. We use FS2 for incremental loading, and for state management on the front end, we use Circe for JSON parsing and JSON encoding and decoding. We use log for CATS for logging, and also using Scala test with CATS effect testing, also with test containers so that we can replicate scenarios very easily with Docker containers spun programmatically. So we have a full-blown development stack for this application. Now, in terms of the architecture of this application, this is a mix between the onion architecture, which has decoupled layers, also mixing with some principles of the hexagonal architecture. So I'm mixing between an onion and hex. I called this architecture Onion X. So we have onion with some layers segmented and hexagonal without the ceremonies with adapters. Now, I'm going to discuss these principles and how they apply to either onion or the hexagonal architecture. So in the onion architecture, we initially have a domain model in terms of which all of our interactions are based. So we have the domain model in terms of which we can implement a repository or a core model, which you can see in the green circle in the diagram. That green circle represents the fundamental operations that we can perform on our domain model. For those of you who are more mathematically inclined, the functional programming equivalent term for this core model would be quote-unquote algebra. So we implement various algebras for the various use cases that we need to implement in our application, which you can see on the left-hand side. So the green slice of that green circle on the diagram can be analogous to the fundamental operations that we can perform with the user domain model. For example, we can have an operation that inserts a user into the quote-unquote memory, which is the database. We can have a fundamental operation which tests whether a user exists or not, whether a user needs to be modified, and so on and so forth. So all of these fundamental operations translate to the green slice of the so-called pizza in the green area in the diagram. On top of that, we have a service layer which implements more complex operations in terms of the fundamental operations described in this so-called algebra. Again, in the use case of managing users, this could be a user service which can perform various complex actions, for example, inserting a user while validating if the user exists or not. So the act of inserting a user must also test whether the user exists and surfacing an error back to whoever called that API. So this service layer is a more complex layer built on top of the fundamental building blocks described in the green layer. Now, moving outward in this onion, we can also describe some more complex interactions still. And in our case, we only have one more layer, which is described by a fundamental REST API or from a user interface described by the web application, which is a single coherent experience for somebody who uses our application, or from the point of view of a bigger jobs platform, for instance, that can consume events from our little jobs platform through an API key. This is again a single coherent experience based out of the fundamental operations described in the layer underneath it, which is in our case the orange layer in the diagram. So from our point of view, the most outward layer in this onion architecture is a coherent experience from the point of view of either the user or the testing or the infrastructure or some other applications that might consume data from our own. So moving back to the left side of the diagram, which is the slice of this onion, we can see an example of user experience. For example, when somebody clicks login and tries to enter their email and password, that is a single experience for them in a single page application, but that is built out of multiple REST calls to the backend. So for example, if somebody wants to log in, that is a single experience for them in the single page application. They click on the login button, they enter their email and password, and then they click the login button. That involves multiple complex operations from the service API. Now, this can very easily be replaced by other experiences from either the user or some other application that might consume such events. For example, we might want to test the application in an integration test, and this layer can simply be swapped for a testing layer that still interacts with the same backend with all the underneath layers intact. Also, we might want to replace the yellow layer with an application that might consume events from our little jobs platform. It would still be a coherent experience from that application's point of view, and our layers underneath the yellow one would still be unchanged. Now, this layered architecture can allow us to replace modules without changing the rest of the application. For example, if we wanted to replace the orange one with a different kind of layer which simply tests the layers underneath, we can simply swap out the orange layer for something else. For example, the one that tests the fundamental operations of the green layer, and so on and so forth. So the onion architecture can allow us to strip away layers that are outside and replace the inner layers with something that is more valuable to us for our specific environment or test case. Now, it's worth mentioning that not all the use cases of the application have all the layers as neatly segmented as this. For example, let's consider another use case of the application, which is another slice of this so-called pizza, which is the checkout infrastructure. The checkout infrastructure is delegated to the Stripe payment service, so we don't really have a domain model of our own, which would normally sit in the center of this diagram. Because we don't really have a domain model, we simply create the fundamental operations, the so-called algebra, algebra, the green area of the diagram, strictly in terms of API calls to the Stripe payment services. And then we can build more complex operations based on the fundamental algebra, so to speak, in the outward layers as usual. So we see here in this diagram that the core module related to payments still has the fundamental operations on top of which we can build a whole payment flow with regards to the user. So we can build a payment service which the web application can access from the UI. So these are some of the principles of the onion architecture that we embedded into this application. Now, let's talk about some of the principles of the hexagonal architecture that we used in this application. Now, in the hexagonal architecture, the core logic of the application, the core business logic needs to stay intact, and there are multiple facets of the application, for example, the user-facing or the server-facing or the testing side of the application that interacts with the same business logic. And because we're using Cat's Effect 3, which is an effect system, this allows us to describe the core business logic as a description of a sequence of computations. And this allows us to keep the core program intact while implementing it in a variety of ways, or testing it in a variety of ways, or allowing the user to interact with it via certain APIs. Now, because we have a full stack application, the user experience needs to interact with some implementations of the backend, and that is done via inversion of control and other forms of dependency injection that are sprinkled throughout the implementation of the backend. Now, speaking of the backend, this OnionX architecture is implemented with tagless final. Tagless final is a very general design pattern in functional programming that allows us to describe programs as expressions which compile for certain kinds of expressions and don't compile for other kinds of expressions. This is the most general form of tagless final. Now, the way that we implement tagless final in Scala for our specific application is that we require the presence of implicit type class instances. So our layers in the OnionX architecture are described in terms of their capabilities by virtue of the presence of type classes. And in this way, we ensure that our layers either compile for certain kinds of expressions and don't compile for others, depending on whether those expressions enable those capabilities or not. So these programs, that is the business logic, for example, the service calls, they're described in very general terms, and the implementation details are only provided later. So the enabler of the capabilities, that is the type class instances themselves, are instantiated last and provided only when those services are instantiated. Now, on screen, you have the definition of one of the layers in the application. This is the authentication module that I use in the real application. So this is actually part of the real app. So you can see the fundamental methods, which are the fundamental operations in this so-called algebra. Now, the way that this authentication module is actually instantiated is by creating a smart constructor via an apply method in the live implementation of that interface by requiring certain type classes. So as you can see in the bottom snippet, the live implementation of that authentication module has a smart constructor in the form of an apply method that requires the presence of some implicit type class instances, either from Cat's Effect or from some other libraries in the ecosystem. And this pattern we follow through the entire application when we instantiate any module. Now, the advantage of using this OnionX architecture with tagless final is that all the layers of our application just click like Lego pieces. If you take a look at the snippet on the right-hand side, this is the code that I use in the real application to instantiate the big core module of the backend that I later use to create the HTTP API. So if you take a look at the for comprehension, it's super clear what we instantiate at what time and how we build the pieces together. So we instantiate the jobs module, the users module, the tokens module, the emails module, the authentication module, and the payments module via Stripe, and then we instantiate the core module by just sticking all of these together. What's nice about this organization is that every single layer or every slice of the pizza has its own capabilities expressed in terms of the strictness of the type class instance that we need to pass in there. For example, monad throw or concurrent or async, depending on the requirements of every slice of pizza individually. This is also very easy to configure because once you configure the entire application, the pieces of those configurations can then be passed to the relevant slices of the core module. So as you can see in the code snippet, some of the modules, for example, the tokens, the emails, and the payment module, the Stripe one, take individual configurations, and those configurations are just pieces of the big application configuration that you can propagate downwards. This organization also makes it very easy to test individual layers without changing any other slices. Now, because the layers or the slices are very nicely separated, it's also very easy to test individual layers or individual slices without affecting the rest of the application in either unit tests or integration tests. And the nicest thing for us, even though it's not quantifiable in terms of performance, the nicest thing for us in terms of developer experience is that this snippet or this code organization is very easy to navigate because it's super clear which module does what. And so if you need to fix a bug or if you need to add a new feature, it's super easy to figure out where you need to insert that code and how you can maintain that. Now, it's not always rainbows and butterflies in the tagless final area because it requires quite a steep learning curve so that you can know all the type classes beforehand and some discipline to maintain the principle of least power, because it's very tempting to always put the strongest type class so that your code compiles, but this defeats the purpose of tagless final in the first place. At the same time, errors, which are quite inevitable, are also quite invisible unless you surface them out manually. If you build a server like I did with an HTTP API and you don't maintain the discipline of logging everything, all you're going to see in the case of an error is a 500 internal server error. And you will have no idea where that error came from unless you start digging, which is a quite tedious process. So you need to maintain the discipline of logging everything so that you can track errors more easily. Now, as your code grows in complexity, tagless final becomes very tempting to misunderstand because as you create more slices of your backend layers with various type class dependencies in there, it becomes very tempting to pass your core layers as type class instances implicitly as well. So as you have Cat's effect type class instances passed implicitly, it becomes very tempting to have all your core modules passed implicitly. This is an anti-pattern, and unfortunately it becomes very tempting to use. So don't do that. Only pass implicit type class instances for capabilities, not for the modules that you otherwise depend upon. The dependencies need to be passed explicitly instead. So these are some considerations about the backend. Let's talk about the frontend right now. The frontend is also built in Scala with Scala.js, and the entire frontend is held by a tiny library called Tyrian. This is a Scala.js library written entirely in Scala 3, and even though it's not a official type-level library per se, it's based entirely on Cat's Effect 3 and FS2. This is inspired by the Elm programming language, and this is best for single-page applications such as the Java's platform that we already built. This library enables pure functional programming, which is always very nice to us as Scala developers. This enables decoupled state management, and I'm going to describe the principles for that decoupled state management shortly. Tyrian is also based on message-based updates, which means that every interaction on the frontend will asynchronously trigger a message, which will then later be handled in a purely functional way. I'm going to describe how shortly. This also enables a first-class HTTP client so that we can interact with the backend very easily, and it also supports Cat's effect-based side effects. Now, in terms of general ideas, I'm going to describe them in more detail with some code snippets shortly, but in essence, an app has a model, which is just a big data structure that remembers the state of the entire application. And the application can receive messages that can arrive at any point. And every interaction from the front end will trigger a message. So every click of a button, every HTTP call, every otherwise asynchronous computation in JavaScript, so in Scala.js land, will trigger a message. And the message is handled by a purely functional update function so that we can create a new model, and based on that new model, we re-render the application. So this is how the state of the application will change, and even the pages will change. Now, let me describe the Tyrian principles in more detail. So this is one of the simplest Tyrian applications that you can possibly add. The application has a model which only stores a single number, and that model is incremented or decremented depending on whether you click one of two buttons on a front-end page. Let me describe the pieces of the application in turn. So the model is the state of the entire application, and a message is a piece of data handled to update the model. So the model is only changed by receiving a message. So message plus model gives us back a new model. The message can be sent by a variety of interactions. It can be sent by a command, which we can emit programmatically. We can be sending a message by a subscription, and we manage subscriptions as wrappers over FS2 instances, so over FS2 streams, and we use this in our real application to manage the state of history changes in the browser. And you can also send messages by creating an event. So an event can be triggered by an interaction with the front end. Now, the concept of a command is the most general way that you can send a message, and a command essentially describes an arbitrary computation that results in a message. It can perform side effects, it can be a pure computation, it can be anything you want. It's essentially a wrapper over cats effect IO. Now, let me describe the core functions that you can use in a Tyrian application. The 4 functions of a Tyrian application are init, update, subscriptions, and view. I'm going to describe them in turn. The init function will create the initial model and will trigger the first command. This will be the bootstrap of your application. So when your application loads, it will start the initial model and maybe it will send the first HTTP request to the backend to maybe fetch some initial data. In my case, for the jobs board that I created, I sent 2 HTTP requests to the backend. The possible filters that the user can check on the left-hand side and the list of the jobs that we already have in the database that we can later populate on the right-hand side of the first page. So this is the init function. The update function is the core function that will update the model based on a message. So like I said earlier, every interaction with the front end or an HTTP call to the backend will trigger a new message. And based on that message, we create a new model. And this may also emit a command, which is why the signature of the update function is a function from message to a new model and a new command that may, for example, trigger a new HTTP call to the backend or some side effects that you may want to run. Now, the way that the messages are being handled inside this update function is usually with partial functions. So the messages that you may want to send inside your application can be very diverse, usually handled in Scala 3 with enums. So it's often useful to handle them as partial function, and they're quite reminiscent of the old Akka style, if you remember that. The next function that we need to implement a Tyrian application is called subscriptions. And subscriptions is just a wrapper over an FS2 stream. And whenever a new element is being sent inside the stream, this will simply emit a new message, which will then later be handled by the update function. And one example you can see here on the screen where every second we emit a new message, which is increment. And for our actual application for the real jobs platform that I've built, I use subscriptions to monitor browser events such as the back and forward buttons and refreshing and the location management of the page so that we can handle a single page application. The final function, but also probably the most important, is view. And view simply renders the content based on the current state of the application. So based on the model, you render something on the page. And this view function is triggered whenever the model changes. So if you have an interaction with the page, for example, a user clicks a button, the button may trigger a message, which may update the model. And if the model changes, then the view function will be triggered again, re-rendering the page. Obviously, there are some smart diff mechanisms in place, both on the Tyrian front and on the browser, so that you don't get any performance hits while rendering the page again. Now, with these concepts, Tyrian is very easy to use and very easy to learn, and you can build as complex an application as you can possibly imagine. Now, the problem is that with just 4 functions, you cannot really build a very large front end without some techniques for scalability. So I would like to talk about how you can scale a front end with the Tyrian library, some good practices to follow if you want to build a more complex application. First of all, the message types. The message types will signify various kinds of interactions either between the components of your application or between the user and your front end. So I'd recommend that you keep the message types in the companion objects of the respective components that will allow such interactions. So for example, in my application, I have a filter panel on the left-hand side, which allows the user to select filters for jobs, for example, countries and salaries and so on and so forth. All those interactions are designed in message types inside the companion object of the filter panel component. You should use seal traits and enums and union types in Scala 3 because it's super easy to define many possible message types in one definition, which is easy to read. Now, as for the functional components of the app, how do you scale your front end to have many possible components that can talk, for example, to the backend in different ways? In this case, you can have many parts in one app. So I would recommend splitting the application into separate modules, and every module will manage its own state. So you'll have functional equivalents of a mini application in Tyrian. So you'll have a model and a state change for every application. So each part will manage its own state, and the big state of the entire application will be made out of the constituent components models. So in my case, I have a filter panel on the left, which manages its own state, and the jobs list on the right, which manages its own state. And the big application model will be made out of those two constituent parts. Now, every message that you receive in the application will fundamentally go through the update function of the big application. So you'll have to delegate that message to the respective component that is responsible for handling that message. And likewise for rendering, in the view function, you should delegate that view function to the respective components. So if you have 3 components on the page, you should simply call the view function on those respective components. And every component will be responsible for its own user interface and for its own visual elements. So these are some considerations about developing the front end of the application with the purely functional Tyrian library. We also talked about the backend. So now let's move on to some memorable moments that I had while developing this application. Now, one source of joy that I always get as a functional Scala developer is to be able to use math to solve some real software problems. In this case, I used semigroups to combine my HTTP endpoints very nicely. So I separated my HTTP endpoints depending on their respective responsibilities, for example, account-related endpoints or job-related endpoints and so on. And I tied them together with semigroups in a very natural way by just quote-unquote adding them to my final routes. Similarly, as you can see here on screen, some HTTP modules had authenticated and not authenticated endpoints, where you have to supply your JWT token. And I very much enjoyed the mental clarity that I got by separating these endpoints and combining them very nicely with the respective quote-unquote add functions that you can see here on screen that are enabled by semigroups and then tying both unauthenticated routes and authenticated routes together. Now, another nice feature was the code that I didn't have to write. At the time I started developing the application, the library pureconfig just added type class derivation in Scala 3, which is very, very cool. And this meant it was very easy for me to define my case classes, which encapsulate different pieces of my configuration, and then just say derives config reader. Because the deriving keyword worked for nested case classes, this fit in very nicely with how my onion layers were segmented as well. Just say derives config reader and it just works. So there was no need for me to create my own given type class instances for my data structures. Just load the config file as a particular type and I was good to go. And you can then assume that you have a case class automatically parsed from your config file, and then you can pass it along to your respective modules. Another one of my proud moments was being able to so-called purify Java APIs. That's because I needed to use the plain old Java Xmail package to be able to send password recovery emails to my users. Now, because this package is very imperative, it had a completely different style than the rest of my code base, and it also produces side effects by nature. So it was a very good candidate for wrapping such code into cat's effect. Now, for this use case, thankfully, the resource API and the resource type in cat's effect is very useful because it closes cleanly and automatically. And you can combine these resources with for comprehensions like you can see on screen. So the code becomes very clear and very clean. And with the combined resource, then I could then use it in a simple funit effect just to be able to send the message. So this simply delivers the message and closing the rest of the resources automatically. And I also wanted to share a proud moment where I wrapped an old callback-based JavaScript API into cat's effect so that I could compress images on the front end. Now, for context, when you post a job on My Little Jobs platform, you're invited to add a company logo or picture for the job. It makes things more attractive to candidates, at least that's what I thought. So the problem is that images can be very big, and I don't really want to store them or render them as big. I had to compress them somehow. So instead of sending the entire image to the backend and have the backend compress it and complicate my code, I wanted to compress it on the browser with the Canvas API. There are JavaScript techniques to do that. So the way that it works is that I'm creating a fictitious image tag that I'm not really showing on screen. And inside that image tag, I create a canvas, which can essentially draw anything with any resolution. So I'm forcing the browser to draw that image into a smaller size, thereby forcing the browser to compress my image and then save that canvas's data into the backend. The problem is that everything is callback based. There are two different layers of callbacks involved, one for the file reader, when you can see on the screen reader.onload, and another callback for the fictitious image tag, where you can see image.addEventListener. The problem is, how do I send a Tyrian message out of that? So I wrap this entire ugly JavaScript code, obviously in Scala.js, into a cats effect asynchronous effect, using the solution to every functional programmer's problems, which is obviously traverse. The argument to traverse is an IO asynchronous effect, which wraps the ugly JavaScript. So the way that this works is that you are given a callback argument in IO async, and you can perform your ugly JavaScript actions. And when those JavaScript callbacks are triggered, I will then quote-unquote complete the IO by invoking my callback argument CB, which you can see in the middle of the code. This async technique is very powerful because I can essentially wrap an arbitrary JavaScript action into a cats effect IO. And because I'm using Tyrian, the result of that IO is a message which will automatically be routed into the main engine of the application, is handled by the update function, and will automatically trigger a page re-render. And everything happens in JavaScript, which is fundamentally a single-threaded environment. This is the most powerful use of cats effect in the entire front end in my application. And finally, I wanted to show you a fast-forward demo of the checkout flow of my application, because the app supports real credit card checkout, which means that you can pay for promoting your job post on my little platform. So you can see here a fast-forward demonstration of somebody paying with their fictitious credit card. This is my little product there. And after the payment is successfully completed, I will then check whether the job is active in my database. So the true flag that you see here in the database means the job is active. So somebody successfully paid for a job advert on my application. I worked a good few days for this little flag in the database. So these architectural decisions and all the good practice tips that I've shared in this presentation are all part of the course that I've just launched, which is called the Typelevel Rite of Passage. In this course, I teach you how to create this exact jobs platform application from scratch, all the way to deploying this app to your own domain, including test coverage, Dockerizing the application, and absolutely everything you need. And at the end of the course, you'll end up with a full-blown product with real credit card checkout, so you can use this app that we've built inside this course as a template for your next application or your startup idea. So if you've ever seen my work at Rock the JVM, you know that I create very long courses. This thing, the Typelevel Rite of Passage, is 3 times as big as my next biggest course. It's by far my biggest project at Rock the JVM. I've worked a whole year on this course, and I hope it will be very valuable for you. So if you want to check it out, just go to my site, and it will simply pop right up. I wanted to thank my friend and former student Ricardo for prototyping what became a good chunk of the back end of the application. I also wanted to thank fellow Scala developer Dave Smith, the maintainer of the Tyrian library, for feedback, and also for merging my little PR that allows rendering arbitrary HTML so that we can render Markdown in the jobs application. And I also wanted to thank the designer and artist at Fellow Noodle for creating the amazing graphic for this course. And needless to say, I wanted to thank you all for coming to my talk. I hope you got some nice insights out of it. I'm now happy to take any questions. Thank you so much.